How do you communicate as a human with nature and the environment? Is it through observation, touch, or even smell? Did you ever imagine all the information input created by only establishing a more connected dialogue with nature? An Australian artist, Natalie Jeremijenko, did. In this lecture, we will overview her fundamental work principles, followed by two projects of her, Amphibious architecture and Mussel Chor, and summarize her contribution to the area. Jeremijenko works through experimental design. She uses technology to facilitate the dialogue between human and ecosystem. With this dialogue, she tries to explore how technology can be used for non-violent social change. Also, as an artist, engineer, and inventor, Jeremijenko works with the idea of citizen science. She seeks to engage common people with scientists in order to create this new interaction with the environment. Next, we'll explore two of her projects in which she used physical computing to express nature data input to human observers.
A great example of those projects is Amphibious architecture. This series of buoys were located in the middle of New York City. They form a fish-sensing, water quality displaying, textable interface to the aquatic ecosystem of the East River. The installation has sonar and hydrophone sensors so that when fish swim underneath it, the lights will go on and make the floating tubes a low-resolution display of fish presence. In addition to that is a water quality sensor which shows the level of the soft oxygen by changing its color smoothly from bright red when the level is low, to a bright green, bluish color when the dissolved oxygen level is high. Through this, the project changes the perception of light, which is normally reflected at the river surface. Now it is rising from the river depths and becomes a part of the city. Here you can see a section of one of those 20 floating light tubes, which is 1.8 meters tall. It has sensors below water and two sets of lighting above water. The upper light signals the dissolved oxygen level as well as the public interest. It is mounted on a threaded rod together with the second light that shows presence and movement of fish. Its Fresnel lens ensures a visibility up to 3 kilometers. The Arduino controller manages all the signals coming from the surroundings. A foam collar makes sure the tubes keep floating and a strong nylon rope connects all the buoys. They are linked for power and signal with marine-grade cables held together with simple zip ties. The signals come through a concrete ballast and move on to the next tubes. The project was developed over 18 months as a collaboration between Jeremijenko's Environmental Health Clinic and the Living Architecture Lab at Columbia Graduate School of Architecture, Planning and Preservation. It took 6 days to assemble and costs approximately $23,000. It was tested first in 2009, and the glass pipe's dynamic array spreads over 60 meters. The team wanted to raise awareness also to designers that the ecosystem we depend on is not somewhere else but here surrounding us. Rivers are public spaces and therefore could be used as architectural spaces. The data we can collect from our codependent ecosystem is already public, but not visible in the daily life of an average pedestrian. This installation displays this data as a public spectacle. Viewers could send text messages and get blinking responses from the buoys. The fish then start chatting about themselves and their surroundings in real time via SMS. Like, "Hey there are 11 of us, and it's pretty nice down here. I mean, the soft oxygen is higher than last week. If you are into comparison, text river river." The visitors then start to look for patterns, explore and discover fish presence, and gain knowledge about what dissolved oxygen level means. Amphibious architecture is an interactive, responsive work that starts a conversation with the river. For Natalie Jeremijenko, this installation does not try to preach or educate, but involve us.
Mussel Chor is a following project of Jeremijenko. It was proposed in 2012 in the Venice Architecture Biennale and further adapted to other spaces. It's an installation in water bodies which collect data from shell movement of blue mussels. This data is then converted into music. Since the mussel shell moves according to the pollution, the music acts as an indicator of the water quality. The artist can detect the movement by equipping each mussel with an IP address and Hall effect sensors. This popular price sensor works by noticing changes in the magnetic field, which produces an output called the Hall voltage. With this output, the artist was capable of assigning each level of a Hall voltage to a musical note. By creating this Mussel Chor, Jeremijenko addresses the public and shows how we can perceive our environment by listening organism behavior. Both projects, Amphibious architecture and Mussel Chor, raise awareness about unregarded ecosystems. Through interaction, it proposes a beneficial living between humans and nature. In her projects, Jeremijenko escapes from screens and proposes physical interfaces. This strategy can allow a more sensorial engagement from civilians. Besides, her projects can act as provocations regarding climate change. Through rethinking our connection with nature, we can also reassess its importance. With this type of provocations, we can see new possible outcomes, as in the project Oyster Architecture from Escape Studios, which use oysters to prevent floating. Finally, it is possible to say that Jeremijenko's work impacts interdisciplinary fields and show us how connections between art, science, and human can generate new perspectives.